for having me. And recording is in progress, of course. Then everyone knows that this will happen. Let me share my screen here. I just have to pick the right one. Okay. And then I will activate PowerPoint. And hopefully you can see me now. Or you cannot see me, but the presentation. Is that working fine?
That's working. Yeah, thank you.
Absolutely good. Yeah, thanks for having me, and I'm really glad to be here. And as I'm a bit the exotic guy, I'd like to introduce a bit on myself and where I am and which organization I'm belonging to. Really unfortunate that we could not meet in person, and I would really love to go there. And I'm pretty sure I will do in the upcoming years, because as you know, Frederick Stahl from my group was formerly working for many years in the UK and is very active in the British Computer Society, and I think there are strong links that will also pull me over. So a bit about my person. I'm a physicist and marine scientist, and I was always very into computer science, using all kind of algorithms and including neural networks, etc. And but I was also always interested in technology, and within my career I was not only at the sea, obviously at several instances here and at sea, and deploying instruments, etc. But I was also for some years in the airborne business, especially in maritime pollution control from airborne platforms and developing sensors there. So, and this will come back, because as life is, things always come back. But my main incentive is really to create tools that enable people to protect and sustainably use the environment, especially the aquatic environment. And so I consider myself as someone who provides tools and methodologies. My current positions are at Oldenburg University, where I have a professorship on marine sensor system at the ICBM, and a scientific director at the German Center for Artificial Intelligence, the DFKI. Well, ICBM is a bit strange name. I know in the English, or in the English sphere, ICBM is the abbreviation for Intercontinental Ballistic Missile. But here it is, let me assure you, it's the Institute for Chemistry and Biology of the Marine Environment, which is an interdisciplinary and very fundamental oriented research institute in the north of Germany. We are also proud home institution of one of the largest research vessels of Germany, the research vessel Sonne, typically operated in the Pacific and Indic Ocean, and have a couple of topics. But we are also involved in the coastal research, and especially everything around the island of Spiekeroog, which is a barrier island in the southern North Sea. This is kind of our backyard, and we do a lot of research there. And I'd like to introduce you briefly, because I need that later on for one of my case studies. Around Spiekeroog, which is a lovely island with a large extended beach on the north side, and more salt marshes, dunes to the southern side, there are many scientific installations, and we framed that into that Spiekeroog Coastal Observatory. One of the longest lasting one is this time series station since 2002, which is located in the gap in the sea gate here between the island of Langeoog and Spiekeroog. And but there are many other locations around the island where research is performed, either by permanent platforms or by temporary installation. One I'd like to also pronounce here and highlight here is the artificial islands in the south of the island Spiekeroog. These are three metal blocks, which 12 of them in total, which mimic different height levels so that we can look at biodiversity experiments and settlement, etc. Again, I'm typically the guy doing the physics and the abiotic observations. I'm not so much into biodiversity or chemistry. Of course, I have to understand the language and talk to the scientists, but my interest is more in observing and measuring. And that's also what my group is about at the university. We develop and operate innovative sensors, often affordable sensors. We develop low-cost drifters, tracking macroplastics. We developed, together with partners from the Netherlands, an app, Ion Water app, to track watercolor across the globe. If you're interested, ionwater.org is a global network of observations and many other techniques around many essential ocean variables and to make that affordable and measurable. Well, I was heavily in this process understanding and sensor development and observatories part, the blue part here on the left, and in Oldenburg since 2011, but also the years before. But over the years, science evolved and you know, software applications, analysis, perception, situational awareness, all these topics came more up and were more relevant to me, also in my science. And that was the reason why I was very happy when I was asked in 2018 exactly if I would like to join DFKI. Since 2019, I'm also a member of the German Research Center for Artificial Intelligence, which is in Germany a very large, I think one of the largest AI research center spread over, at the moment, 5 federal states, but there are more locations coming up. So we will extend our operations. And DFKI is also strongly involved in European initiatives like CLARE or Humane AI. And it's widely known often for its, for example, for the Robotic Innovation Center, for innovations in mobility, Industry 4.0, strongly pushed also by Wolfgang Balster, the former CEO of DFKI, and also natural language processing and so on. Then I joined this group and I brought a complete different perspective into DFKI, an environmentalist perspective, and perspective of sensing, perceiving, understanding nature, and how we can use analysis of multisensory data using AI methods, and how we can perform real-time data stream analysis, and how to combine all of that to provide guidance and support to stakeholders in sustainable activities. So why do I care, or why should you care about the marine science? Well, that's a bit carrying old to Athens, because in the UK you're a seagoing nation, and the sea is all around you, and it's very strong also in marine science. But of course, I mean, as we are here in the computer science workshop, I'd like to just point out that while you're sitting there and listening to me, every second breath you take, you owe to the oceans, because it's nearly 50% of global oxygen production is coming from marine algae. Also, the oceans feed us with their large biodiversity and the origin of the food chain. Also, they are a home to many people, not only Northern German and UK population, but 50% of human population lives nearby the coast, and most of the mega cities are. So it's highly relevant, but they are also at risk, of course. And oceans are at risk by global warming, by sea level rise, acidification, pesticides, nutrients, sewages, litter, and many more. So it's needed. We need AI to tackle problems, and that's and I will dive into 2 example cases here in the following minutes, where I will look into the different applications from my sphere. The first application I'd like to look in is coastal oceanography, from time series analysis to change detection and digital twins. And what you can see here on the drone image that I took is are these artificial islands that I mentioned before. So these are 12 islands set up on different levels. I mean, this is a primary zone. Then the lower next level is the lower salt marsh and the upper salt marsh, and there are many sensors deployed around them. So this is an ongoing biodiversity experiment with to understand more the settlement and the reaction of nature towards sea level rise. We used this or located them within this Spiekow Coastal Observatory because we have a high amount of different observational platforms in this area, and many sensors, many parameters, so that we can kind of link data and have a longer timeline or time series understanding of the processes happening around these artificial islands. But the truth is also that even if you operate since 2002 such an observatory, not all the data is continuously available. There are many issues with sensors in their daily operation. And I can really tell you that this is a big trouble and a lot of work to maintain stations and sensors and then later on taking care of the data. And here the time series station, and this is a current meter with an additional temperature and oxygen and salinity probe attached, which is located by these islands, nearby these islands. These data, for example, this recording current meter has several dropouts over a time period of 3 years. So this is from a data paper I published on ESSD, and where I looked into several of the sensors around the artificial islands, and this is the availability of the data. And you can already see that not all of the data is available at all times. Okay, some sensors might be deployed later, but there are always also cleaning times, dropout times, the sensors are toppled over by the sea or by boats. Many things can happen that kind of provide or lead to gaps and data missing that you really would like to have in the system. So one of the first things we started in collaboration with Oliver Kramer at Oldenburg University was work by Stefan Oehmke, and Stefan looked into how we can impute gaps. So it's very easy if you have a gap of just one data point missing or 2 data points, and filling it in a linear way is easy. But once you start to have longer gap time periods, you have to think about the dynamics. This is a tidal regime. Water is coming in and out. There are always there are other effects, nip tides, ebb tides, spring tides. So there are many processes happening. And so what we used here were first simple outlier detection to clean the data, also took care of some shifts. And then and gap imputation was developed, which used k nearest neighbor and some distance metric changes, which performed much better in the way that before. And then we in the second step, we thought, okay, what happens if a sensor fully drops out? This recording current meter, I just jump back here. This one recording current meter with a red hat, it really dropped out after some time. It was it had a strong failure. We had to purchase a new one. It took us some time. And therefore we thought, okay, can we derive reasonable data for this sensor based on the historic data set? So a virtual marine sensor architecture was developed called MarineNet, which was a combination of some convolutional modules and time dimensionality reduction and LSTM layers, which then performed pretty well in kind of bridging the gap of such a sensor failure. That was encouraging, and so we moved on, and recently we started a project in my group at DFKI called CHESS, which is stands for Change Event-Based Sensor Sampling, and the main topic here is to look for events and anomalies, but also for changes, recurring changes, gradual changes, or incremental changes happening in a natural system, and to trigger, for example, water sampling by such a water sampler device, which is then located in the time series station, but also to adjust, for example, a sampling scheme. If an event happens that you want to observe, you kind of increase your measurement rate, and later on you can decrease it again. But also you can use this concept change detection for detecting sensor fouling. It's something which is happening very frequently, and then you can initiate cleaning, or you can retrain your model when concepts have changed. So there are many reasons and many applications where this kind of concept change detection is really key and helpful. We then implemented now a first step here of this concept change detector from a paper from Daniel Lukatz et al. From my group, and also could use it in this first instant here for detecting anomalies inside multivariate time series. This is only one parameter shown. The key is that it's across all the parameters. And also recently we used it for detecting concept changes, and not only for this time series station, but also for inland water, freshwater systems, but also for vessel-based systems. If you're interested, I encourage you to contact Frederik Stahl from my group. He's a responsible scientist for data stream mining and analysis, and also the PI behind CHESS. But going beyond the time series, there is one trend I currently see, which is the advent of digital twins. You know, digital twins is a concept from which is known in engineering for many years. You have a machinery and you build a digital representation of it, and then you can kind of test different scenarios, also use external information and kind of develop a framework where you can test, manipulate, and also reprogram then the real world. So this interaction between real world and twin is what really makes it attractive. And now in the recent times, it had been enlarged also on global scales. There is the Destination Earth initiative of the European Union. And this Destination Earth is really aiming to have digital twins of the Earth on different levels. But there's also very interesting digital twin initiatives on the ocean, the DITO initiative, or from the G7 under the United Kingdom lead, the Futures of the Seas and Ocean Initiatives, FSOI. And there, one of the main topics is realizing a digital twin of the ocean capacity, which I think is really looking forward, and it will be carried on, I can tell you, during the next presidency, which is Germany from January on. And one of the key contacts here is Martin Fisbeck from GeoMar, and driving that. But back to digital twin Earth on the European level, the European Union well, ask ESA, ECMWF, and EUMETSAT to develop and support this structure. And as one element, ESA contracted DFKI in an ESA lab to look at the elements where AI could aid the development of these digital twin Earths. And this is an interesting project, a scoping project, which just started. And in our part,
I've not had my second cup, darling.
Take yours then.
We can hear you. In our part, we are responsible for the offshore wind farm effects, which is a specific application of the digital twin here. We will look at wind farms and their effect on the marine environment, how they change the stratification of the marine environment, the food chain, how wind farms have not only effects in their specific area, but also 2, 3, 4 times their diameter in the surrounding areas due to the effects on the wind field and on the waves, the ocean currents. And to that end, we will use Earth observation data from satellites like Sentinel-3, but also in situ data. And from this project, I share with you this conceptual drawing where we identified in the early stage where at which points of this infrastructure that ESA is planning, an infrastructure of different layers, with an infrastructure and data service layer at the bottom, and then the model service layer, and on top is simulation reasoning layer. But the small text here is providing some hints where AI is relevant. And from explainable AI and natural language processing at the simulation reasoning layer, and also knowledge graphs, to on the model layer, a lot of this self-learning, uncertainty neural network, and so on, classification topics, but also then on infrastructure layer, how to work with the data, how to transform autoencoder, CNNs, and also our k-nearest network and imputation topics. So AI will be everywhere in the...
Whether the little more milk and finish the carton, because they looked very dark.
Okay.
The second application I'd like to highlight here is another topic which is highly prominent in media and urging us to find some solutions. It's a litter problem and the plastic problem. And to provide a short background how I came to that topic, I work with spectral sensors and spectral observations, and we were happy to join an initiative of the ocean cleanup where they hired a large aircraft and just crossed the Great Pacific Garbage Patch in the North Pacific, and use different camera techniques, but also spectral sensors in the shortwave infrared. And we use that for detecting the plastic and discriminating the plastic types, and looking for how much it's submerged. This received a bit of awareness, and due to that fact, World Bank addressed us and approached us and thought about, well, can we transport that technology to Asian countries, first to Cambodia, and to support our activities there in better waste management and detecting litter at beaches and also in the riverine systems, not on aircrafts, maybe on drones. And then we thought about, okay, how can we develop that and how can we make that affordable? How can we build up capacities, and how can we use that technology best? It quickly turned out that we cannot use aircrafts, and we cannot use shortwave infrared hyperspectral imagers, which are in the price range of some 100,000 euros. But we have to think about an affordable, easy to use methodology that stakeholders can perform and maintain on their own. So we changed completely to commercial off-the-shelf drones. and to their RGB cameras. We also investigated some other wavebands, but at the end, it turned out that really off-the-shelf technology is the way to do that. And then we put, instead of bringing the effort to the sensor platform, we brought it to the, we used it in the analysis. So we developed a two-step machine learning solution, here published by Mathis Wolf from my group, and where we looked first in Cambodia on different data at beaches, at rivers, but also in canals where it was highly accumulated. And then we developed a CNN architecture which we trained with segmented images. So we took the images that we received, the image that you see up here in the upper level. Sorry for the quality. The quality is a bit better in real. And then we segmented that in small tiles. And these tiles we used a training. We set up a training data set and a validation data set. And we had two CNN architectures, one for the detection of the general classes, which were 5 classes, PLD, the detector, which can just separate water from vegetation, from sand, from litter, 2 classes of litter and other, with about 6,000 tiles for training. And then we had a finer grid of the plastic discriminator or qualifier, and that was made up from 18 classes, but we had also some issues with some classes which were less populated, and that of course is always a topic I will address it a minute later. But yeah, so we set up this training set and trained the network, and it always works like that. We have an input image. We analyze it, we cut the image into tiles of 100 by 100. Now we changed the size a bit in recent approaches, but more or less. And then we perform this classification to separate water from litter and vegetation. And with this information, we just go to the next level. And now we only analyze the areas where litter is observed, either high or low litter concentration. And then we perform this classification into 19 or 18 classes, which are derived from international observation standards. So what we end up is we have at the end, we get an area covered. We can estimate the waste volume. We see what types of waste we have. And especially we know what are the top 5, top 10 items. That's especially what the World Bank and United Nations program is interested in. What are the top items that we can, so that they can change policy to prevent them from entering their nature. As I just promised to talk also about the shortcomings. Well, the PLD is well trained and well performing, but it's definitely that I mean, it's not astonishing, but just to say that of course data curation is needed. You need the training data set. We improved our results recently through more data, but also through higher quality data. We use many augmentation techniques to, especially for the classes which are low populated. And there are still sometimes issues with illumination, for example, or sun speckles. Illumination issue here on the right-hand side on the 2 lower images, where you can see a strong shadow changing the classification result. And we are looking forward to implement other image optimization algorithms to run them prior to this analysis, so that we can prevent these events. Just to give you a short zoom into how this works. An example from our work in the Philippines, well, starting from Cambodia, we also worked in Vietnam and in the Philippines and in India, and then in Indonesia. Then we also worked in Europe and several in Bosnia and Herzegovina and Serbia. But it typically works like this. From an overview, satellite overview and local knowledge, there is a selection of potential sites. I mean, drones do not fly the whole Pasig River in Manila, but you pick your tributary canals or riverbanks that you want to investigate. We also worked with satellite observation people to identify these spots from satellite. That's another work I will not show today. Then going to these locations, we perform higher altitude flights in 60 to 100 meter altitude to have an overview. Also here we can use AI to detect hotspots. And then we go down to 6 to 10 meter altitude and perform often an automosaic pattern, but also single images, which then provide us with a high resolution input that we then use for the analysis. And again, we have this two-step analysis. That means in the top, you can see the coarse analysis of litter, yes or no, and heavy, strong, and weaker litter. And in the lower one, you can see the detailed analysis. And from that, we derive statistics, and the statistics is basically what World Bank and other authorities are interested in. They want to know what are the main polluters, like here, cups, lids, caps, bottles, food wrappers, and polystyrene, which is often packaging of food. And also we use this technique, as I said, in other countries, for example, in Vietnam. Some other examples, it's not only these highly polluted areas on the left-hand side in Hai Duong, but also Haiphong and Shandong, other areas where you see often these vegetation, where litter is captured. And also in Vietnam and Philippines, we used cameras also on bridges and did time series analysis, which I will not show with respect to time here. So my overall vision is to combine these observations from drones, from rivers, from satellite, but also model-based and integrate them into an AI-enhanced digital twin again, and then to derive information also for cleanup operations, but also for policymakers. And part of this cleanup operations are these boats here, which are used, developed in Germany by a company called Berkey. They typically, these are mowing boats. They had been reconstructed to collect plastics and litter from water bodies. And we are currently equipping them also with AI enhanced cameras, which are then enabling them to directly measure how much litter they carry on and what is the quality, so that in the later on recycling steps, this information can be used. And that's really a hint that AI is strong in any recycling application. That can be very helpful. The next step in this project, starting from next year on, will be plastic ops, where we will go back to the aircraft. And I said in my introduction that I started also my career with working on marine pollution aircrafts. And now we had the idea, if we can use these aircrafts, which are typically used to spot oil spills, if we can also change them, modify them in a way that they can also help us with plastic, tackle the new problem. And so the project will look at fast edge AI systems which can identify hotspots and then direct an Earth and electro-optical imaging system towards the spots and then perform the analysis. So this is some work which we will perform in the next 3 years. And we are glad to have the support from Ministry of Environment here, and a couple of partners involved. Well, I picked 2 examples from my area, and there are many more applications in marine science where AI can help. Obviously, the whole robotics area is absolutely affine to any artificial intelligence support, and robotics in itself is an artificial intelligence domain. But also, yeah, I mentioned digital twins. There will be other data analysis, spectral analysis going on. So there's a lot more to come. But in my final part, I want to change the perspective a bit and try to answer the question that was also raised with announcing this presentation. And as a presentation is titled also, "Is AI a game changer?" I want to address this aspect. Well, spoiler alert, I think it's not, it's an enabler, but it's a very powerful tool. I mean, I don't have to convince you on that. It's a powerful tool which we can use to many of the global challenges that we're facing. And also throughout this conference, we have seen some application areas where this has been used, and today it will also be a topic. I already mentioned circular economy and energy transition, mobility, industry 4.0, but also other topics like resilience or food security. A good way to look at it from a more general perspective is the SDGs, Sustainable Development Goals, which you all know, 17 SDGs, and I mean, they are even communicated in kindergarten, and they kind of structure the aims and of the United Nations for a more sustainable global society. These 17 goals are substructured in 196 targets. And if we want to know if AI can contribute, there is a nice paper from Venuesa et al. In Nature Communications from last year, where they directly investigated these SDGs and where AI can contribute. So they did a literature review and also interviews and looked into the different SDGs areas from 1 to 17. They grouped them into the group environment, 13, 14, 15, and society and economy. And they investigated where do they have more positive or negative impacts. And they found a lot of positive aspects where AI can be used in following SDGs topics. 79%, the negative ones are by 35% in their study. The sum is beyond 100, of course, because often or sometimes negative and positive effects happen at the same time, maybe in different areas. But so this is encouraging, I think. But also they said there is a but. The but is that that often these examples are more or less lighthouses or isolated lab solutions. So they need a broader application, and for that the authors pronounced and highlighted that we need to integrate them. That social acceptance by individuals, but also by governments, is very key to any technology that will help in an environmental topic, and that we need to think that and strengthen that. So societal acceptance and legal frameworks are needed, and real-world laboratories are one way to achieve that. And so I also like to advocate for real-world laboratories. There are many studies also that looked into that topic. The famous World Economic Forum study, Harnessing AI for the Earth. Some recent studies from Vodafone Institute, Cambridge University on the AI Gambit, and others very recently published on the COP26 by the Climate Change and AI, which is addressing directly where AI can help to tackle climate change. which is very, there are many aspects, if I dive into that, where AI can help. For example, here the green boxes, of course, in all of the climate mitigation, but also in the climate adaptation. It can help, of course, in industry, energy, mobility, but also with extreme events, and also in the literature, research, in deep learning for climate data and climate modeling. So there are many areas where AI can support these efforts. Of course, they also highlighted that we have to look into the energy consumption and also other drawbacks of AI, where we have to look at the footprint. And you might be familiar with that concept, if not a brief introduction into the concept of green AI and red AI from Schwarz et al., where Schwarz et al. Especially looked at the deep learning with its strong success rate, but also the energy demand, data demand, and also sometimes the lack of transparency in a way that and reusability that they complained about, and that they said, okay, we need a more green AI that will be more, that's more looking at efficiency and not only at accuracy, but also promotes reuse and transparency and inclusivity. And also, given the background of the growth of edge devices that I see, I think we need to think a bit more sustainability by design when we design our AI applications from the whole life cycle. I mean, the data, the model, finding the model, hyperparameters, training, implementation, hardware, the whole lifetime needs to be considered under sustainability aspects. So final slide, and with from a higher perspective, I'd like to advocate for that we use AI for sustainability, where it has really great, enormous opportunities, not only for the marine environment, but for environmental application and sustainability goals at large. And but we have also to think and implement AI in a sustainable way, we have to think about also societal acceptance. That means also that we cannot separate ethical issues from sustainable issues. So we have to think about transparency and acceptance and all of that. And so I think AI is not a silver bullet. It's a means, it's a tool, it's the enabler for sustainability transformation. But if we can use it, it's a very powerful tool. And therefore, also within the DFKI, I founded a year ago, 1.5 years ago, I founded an initiative across the whole institute, which is focusing on this topic, which is called DFKI for Planet. If you're interested, you're happy to contact me or have a look at our website here. Okay. And with that, I'd like to finish here, and I'd like to thank you for your interest, but also like to thank all our supporters and funding agencies, and especially my team or teams at Oldenburg University and at DFKI. Without this work would never be possible. Okay, and just let you look at the research vessel Heinke here for another minute, and then no, I will stop that. Good. Anyone alive?
Is my microphone working now? That's better.
Oliver, you were scaring me. I mean, this is the moment when you think that 45 minutes you were talking to your computer, but no one could listen.
Thank you very much for that absolutely fascinating lecture, covering such a wide range of topics, from AI, but also into sustainability, into much wider issues, and your challenges of managing things across many organizations and many countries must be quite a challenge. I'm sure there are some questions. If people, as we did yesterday, wanted to put their questions into the chat, then we can see if Oliver can answer some of those. We've certainly got some time for questions. So has anybody got a question?
Also open. I think it will always take a second in Zoom also to think about and type them in.
Okay, a couple of questions there in the chat. Rosemary, would you like to start with the first one?
It wasn't so much a question as thanking Oliver for such a great presentation. It highlighted so many items that are currently of great interest, and I'll definitely be following his work from now on. It sounds really good.
Thanks for that, Rosemary.
Yeah, thank you. I like to provide you with an overview and some. I mean, it's always good to know what we're doing is relevant. There's Andrew.
Yeah, Andrew, would you? A
Yes.
lot of the came up today. Hark back to the discussion we had on AI and sustainability yesterday, which Andrew led. So, Andrew, what would your question be?
Yeah. Yes. Thank you. Fascinating talk there. We've got a strange echo on the line, haven't we? More of a meta question, really, rather than a technical one. Would you agree that sustainable issues actually are ethical issues, and that's why we really just can't separate the two out?
I think that's a really valid point. I mean, it's a sustainability is an ethical issue. It's a fair chances that the future generation has, and we have to consider them. And I think it's a good point. But often when I'm invited in different audiences, etc., these are separately looked at, and often we end in ethical issues. We have a lot of discussions about medical applications and data and etc., and who belongs which data and what can we do. But in the environmental aspects, we don't see that so much. So but if we want to include people, if we want to make data available, if we want to encourage people and also provide them with trust in what we're doing, we need to open up this discussion also on the ethical issues so I'm fully with you. I would also say that this is not something separate. It's the same stuff. But maybe when you merge it, you will lose the focus on sustainability, because ethics is often directly going in different topics.
Thank you for that. Ginger, you seem to have a couple of questions. Would you like to speak up? No.
I can pick up the question. Ginger's question here is very clear. On the EU level, I haven't seen this effect, but I know that from this strange echo, maybe people not actively can maybe mute their mic. In Cambodia, our results were really used for policy making. So Cambodia implemented new policies on how to use single-use plastics and also industrial chains, etc., on recycling, and directly results from our observations were used to implement new policies, and also on the regional scale, because with the observations that we made, we could also identify areas where the waste management was not really implemented, or where specific sources were stronger than in other areas. So this could be used to also on a regional scale to change policies in certain cities like Siem Reap or so. So in Cambodia, I'm well aware that this had direct effects. Our applications in Europe have been in the context of infrastructures which were flooded with litter after strong rain events. And but I'm not aware of EU policy that changed in that respect. It's more an awareness thing at the moment.
Thanks very much for that. Perhaps one more question, Ada Ashrafi, if you'd like to ask your question.
Thanks, Oliver. That was a great talk. I'm actually also a first-year PhD student working on the use of AI for sustainable fisheries. I'm mostly working with the AIS data and trying to detect fishing activities from the data, which are the movements of the fishing vessels. So I was, and I'm facing the limited labeled data. So I was wondering if in your experience, this semi-supervised or maybe unsupervised methods have been good enough. I would be happy to have your opinion. Thank you.
Yeah. First of all, yeah, semi-supervised methods will be very key also for us in the future. The whole approach that I showed so far was supervised, and the labeling was the most intense part. And I mean, you're aware of that, presumably, that also most of the work goes into labeling, and then you have some classes which are sparsely populated, and then you have to augment them and think about them. So this is a really issue. And so unsupervised, semi-supervised, or interactive machine learning, where you have unsupervised methods and that can then feedback on human experience, will be key. For example, when you have new pollutants, with the pandemic, we suddenly had face masks and other medical equipment in the pollutions, and we had to completely to train a new class, etc. So and it would be much more flexible in that way and much quicker. So I fully agree that this is one of the future ways. On the one hand, we have to think about the quality of the data that we put in and spend more efforts in that. On the other hand, we have to work with less data, and therefore unsupervised or semi-supervised methods are key. In the field of the event and change detection, we already use that because events are happening very rarely, and you have problems in finding enough supervised labeled data here. So also there we try to be either interactive or yes, unsupervised. So very important topic, I think, absolutely.
Oliver, many thanks for an absolute fascinating talk. I can see from the comments that everybody thoroughly enjoyed it, and thank you for joining us. As Max said yesterday, I'm sorry that Zoom doesn't have an applause facility to thank you, but I'm sure everybody would wish to clap and thank you for your talk. Thank you very much indeed for joining us. Thank you.
You're very kind. I really enjoyed it.
And perhaps hopefully see you in the conference again in future years, as you said.